This is Spacetime, Series 25, Episode 49. Coming up on Spacetime, why Venus rotates so slowly and in the wrong direction. NASA's Mars Perseverance rover arrives at its primary target on the red planet. And humanity's latest proposed beacon to the galaxy. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
A new study suggests that Venus is gravitationally tidally locked to the Sun, and that explains why it's so strange compared to the Earth. The findings, reported in the journal Nature Astronomy, may help to address some of the many questions about Earth's sister planet which need answering. Venus and Earth are almost exactly the same size, and were formed in the same part of the solar system, out of the same materials, and under similar conditions. Yet while the Earth is a warm, wet world capable of supporting a vast array of life in all its many wondrous forms, Venus is the nearest thing to hell in our solar system. It has a surface temperature of over 460 degrees Celsius. That's hot enough to melt lead, and a thick cloud cover crushes down the planet's dense carbon dioxide atmosphere, giving it a surface pressure 100 times greater than that at sea level on Earth. When it does rain on Venus, it rains sulfuric acid, with metal snow falling on the mountaintops. And finally, the planet rotates backwards, with the sun rising in the west and setting in the east, and so slowly, a Venusian day lasts longer than its year. Some scientists speculate that were it not for the soupy, fast-moving atmosphere on Venus, Earth's sister planet wouldn't rotate at all. Instead, Venus would be tidally locked in place, always facing the sun with the same side, in the same way that the same side of the moon always faces the Earth. The gravity of a large object in space can stop a smaller object from spinning. It's a phenomenon known as gravitational tidal locking. And if that is what's happening on Venus, scientists argue that the atmosphere needs to be a far more prominent factor in studies of both Venus and other planets. The study's lead author, Stephen Kane from the University of California, Riverside, says people think of an atmosphere as a thin, almost separate layer on top of the planet, something that has minimal interaction with the solid planet beneath. But Kane says Venus's powerful atmosphere teaches science that it's far more integrated with the planet and that it affects absolutely everything, even how fast the planet rotates. Venus takes 243 Earth days to rotate once on its axis, but its atmosphere circles around the planet every 4 Earth days. Extremely fast winds cause the atmosphere to drag along the surface of the planet as it circulates, slowing its rotation while also loosening the grip of the sun's gravity. And slow rotation in turn has dramatic consequences for the sweltering Venusian climate. Kane points out Venus is incredibly alien. One reason for the heat is that nearly all of the sun's energy absorbed by the planet is soaked up by the Venusian atmosphere, never reaching the surface. He says this means that a rover with solar panels, like the one NASA sent to Mars, simply wouldn't work there. And the Venusian atmosphere also blocks the sun's energy from leaving the planet, preventing cooling or the pooling of liquid water on the surface, and giving the planet its runaway greenhouse effect. Kane says it's unclear whether being partially tidally locked contributes to the greenhouse state, a condition which ultimately renders the planet uninhabitable as we know it. But he says not only is it important to gain clarity on this question to understand Venus, it's also important for understanding exoplanets likely to be targeted in future NASA missions. Most of the planets likely to be observed by the James Webb Space Telescope are very close to their host stars, even closer than Venus is to the Sun. Therefore, they're also likely to be tidally locked. And since humans may never be able to visit these exoplanets in person, making sure computer models account for the effects of tidal locking is critical. This is Spacetime. Still to come, Perseverance arrives at its primary target on the red planet, and humanity's latest proposed beacon to the galaxy. All that and more still to come on Spacetime. NASA's Mars Perseverance rover has finally arrived at its ultimate destination on the Red Planet, an ancient dried-up river delta in Jezero Crater that may provide evidence of life on another world. The car-sized six-wheeled rover, which arrived on Mars in February last year, has been exploring geological features to the south and west of its landing site to investigate and sample several of the deepest and potentially oldest accessible geological units in Jezero Crater. The CETA unit, which means amongst the sand in the Navajo language, and the cratered floor fractured rough. Along the way, Perseverance, guided by its tissue box-sized Ingenuity helicopter, has collected 8 samples of rock core and regolith for eventual return to Earth. Subsequent joint missions between NASA and the European Space Agency will send spacecraft back to Mars to collect these sealed samples from the surface and return them to Earth for more in-depth analysis. After visiting CETA and the cratered floor fractured rough, Perseverance undertook a record-breaking 31 Martian day or Sol dash across some 5 kilometers of the Red Planet's landscape, retracing its route back to its landing site before heading northeast around the rim of a crater, before turning northwest to ultimately reach a point dubbed Three Forks by mission managers because it's the spot where 3 different route options to the delta merge. From Three Forks, Perseverance can access geological locations around the base of the ancient river delta containing sediment washed down from further upstream billions of years ago. The rover will then ascend the delta by driving up a valley wall to the northwest, collecting samples as it explores the ancient and now dried up river channel. Head of NASA's Science Mission Directorate, Thomas Zabukin, says the delta at Jezero Crater promises to be a veritable geological feast and one of the best locations on Mars to look for signs of past microbial life. He says its exploration tops the Perseverance science team's wish list because all the fine-grained sediments deposited at its base long ago is the mission's best bet for finding preserved remnants of ancient microscopic life. One goal of this excursion is to scope out the best route to ascend the delta, which rises about 40 metres above the crater floor. Right now, there are 2 options which look traversable. One's called Cape Nutshak, the other Hawksbill Gap. Now, at the moment, the science team are leaning towards Hawksbill Gap because of the shorter drive needed to reach the top of the delta. But that may change as the rover acquires additional information about the 2 options. Whichever route Perseverance takes to the plateau atop the delta, the team will perform detailed science investigations, including taking rock samples on the way up and then turn around and do the same thing on the way back down again. Current plans will see the rover collect around 8 samples for eventual return to Earth during the journey, which should take about half an Earth year to complete. Now, after completing that descent, according to this current plan, Perseverance will then again ascend the delta, this time probably going by the alternate route, another excursion which will take about half an Earth year. Remember, this delta is the real reason why Perseverance was sent to Jezero Crater. Scientists will look for signs of ancient life in the rocks at the base of the delta, rocks they think were once mud on the bottom of Lake Jezero. Higher up in the delta, they'll examine the sands and rock fragments which have come from upstream, perhaps originating many kilometres away. Perseverance is kicking off its new science campaign more than a month earlier than planned, thanks to the rover's ability to autonomously navigate Jezero Crater's sandpits, craters, boulders, and fields of sharp rocks. The rover's artificial intelligence-assisted auto-navigation capability, or AutoNav, assessed some 10,744 navigation images during the road trip and commanded the rover to halt and turn in place to negotiate different surface hazards some 55 times. And all that in just its first year of operations. This is Spacetime. Still to come, humanity's latest proposal to send a message out into the galaxy. And later in the science report, a new study warns that microplastics are now finding their way into the human food chain in ever greater numbers. All that and more still to come on Spacetime. Scientists have developed a new proposal to send a greeting from the people of Earth out into deep space, letting the universe know we're here. According to the Drake equation, our galaxy alone could be host to thousands of intelligent alien civilizations. Put simply, the Drake equation looks for n, that is, the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable by us. N equals R. That is the rate of formation of stars suitable for the development of intelligent life per year, times Fp, the fraction of those stars with planetary systems, times Ne, the number of planets per solar system with an environment suitable for life, times Fl, the fraction of suitable planets on which life actually appears, times Fi, the fraction of life-bearing planets on which intelligent life emerges, times Fc, the fraction of civilizations that develop a technology that produces detectable signs of their existence, times L, the average length of time in Earth years such civilizations are around to produce such signs. Now, in reality, the Drake equation is nothing more than a bunch of estimates, the value of each of which are totally arbitrary, limited only by your imagination. But it does raise the question of whether or not we're alone in the universe. Now, if it turns out we're not alone in the universe, you then got to ask yourself another question. Is it a good idea to let the local Klingons and Cardassians know we're here? See, this goes against the advice of the late physicist and cosmologist Stephen Hawking, who warned we only need to look at our own history to teach us how more primitive civilizations tend not to do very well once they encounter more advanced civilizations. You only need to look at the lessons learned from European colonization of Africa, South America, and Australia. But do we learn lessons at all? NASA's twin Pioneer spacecraft, launched in 1972 and 73, were each fitted with the first messages to humanity specifically designed to travel beyond our solar system. A pair of plaques depicting a line drawing of a man and a woman, we knew the definitions of those back then, and symbols meant to show where the spacecraft originated. Then in 1977, the twin Voyager spacecraft, under a program initiated by Carl Sagan, were equipped with golden records containing far more information, including music, animal sounds, and spoken greetings from the people of Earth in 55 languages. Of course, ever since humans have been broadcasting, their signals have been travelling across space at the speed of light. So, theoretically, if ET has a powerful enough receiver, they could be tuning into old episodes of I Love Lucy, or worse still, seeing images of Hitler opening the Berlin Olympics. Back in 1974, astronomers used the giant, now gone 305-meter Arecibo radio telescope in Puerto Rico to send out a message, deliberately telling anyone listening about us. That message used binary code to convey information about humanity's base 10 counting system, common important elements, and a map of the solar system to let people know where we are. The Arecibo message was sent towards a globular star cluster called M13, located some 25,000 light-years away, so it's still got some distance to go. Now, to mark the 50th anniversary of that 1974 Arecibo message, a bunch of scientists from NASA's Jet Propulsion Laboratory in Pasadena, California, have submitted a proposal on the pre-press physics website archive.org to send out a new message. This new greeting would encode information in binary and describe basic maths, physics, and biology, including descriptions of DNA, amino acids, and glucose. It would also contain a map showing the way to our Milky Way galaxy and how to get to our solar system using globular star clusters in the Milky Way as signposts, rather than the pulsars used in the original 1974 map. The new directions show exactly where the Earth is located and provide details about the planet's composition and atmosphere. Everything you'd need to know, really. And to convey a temporal component, the authors would use a characteristic of the neutral hydrogen atom found in interstellar gas. It's the most common element in the universe. Neutral hydrogen can enter a high energy state after colliding with other atoms or electrons, and then transition back to a lower energy state in a spin flip transition after around 10 million years. And it's this timing providing a universal unit of time for communicating exactly how long after the Big Bang the message was sent. Astronomer Brad Tucker from the Australian National University says if the new hello message is sent, the current target is a ring of stars about 13,000 light years from the Milky Way's galactic centre.
The idea, and this is all from a paper that was recently written and put on what we call archive. This is the pre-publication server, so hasn't gone through full referee process yet. But the idea is, well, we have a lot new, more powerful radio telescopes and facilities. And with further upgrades, they have the potential to release a lot of power, essentially energy. And we also have updates and advances in computer algorithms and things like that. So why don't we take advantage of it and use it to send a very powerful radio signal to the heart of the Milky Way. So the idea here is that you aim it towards the center of the galaxy, where you're likely to encounter lots of stars and planetary and stellar systems along the way, and increase your chances of it going by or near or seeing by some potentially habitable, intelligent civilization if it exists.
Would that be the right direction? Doesn't everything we know about planetary science tell us that maybe we should be looking more in our own neighborhood or further out towards the outskirts of the galaxy?
So you're right. So the Arecibo message happened in 74. I think it was 74, you're right. So, we're almost 50 years, and that's kind of the inspiration for this. And that was done with the Arecibo dish in Puerto Rico, which is now no longer working.
May it rest in peace.
That's right. Pieces, unfortunately. And it was directed at a cluster of stars that was, I think it was 12,000 light years away, something like that. So clusters of stars in the Milky Way, but a densely populated area of stars. At the time, the thinking was, well, keeping in mind, in the 70s, we had never even seen another planet around another star. That first discovery was back in the 90s. And now what we know about clusters is they actually are very poor places to host planets. So that wasn't maybe the best message. But yes, nowadays it's kind of thinking, all right, well, can we do it? So here the argument is, you're right, we do know where the likelihood of planets lie. They are in less dense populated areas of stars and clusters, so more towards the arms of a galaxy rather than the core of the center. Here, I think their argument is just quantity, that if you're looking towards the center of the Milky Way, well, other civilizations are likely to be looking at that as well. So it's not just anything that we come in the path, but it's a popular place to look, because if you're intelligent, of course, you're studying astronomy, you're looking towards the densest part of the galaxy, which happens to be towards the center.
I guess the one question we should be asking isn't just could we, but should we?
And this is kind of the point of discussion that a lot of people are having now, is, what is the purpose? What is the benefit? What are the consequences? And this is, I think, a very important question when we talk about aliens. And I mean in the truest sense, not just intelligent life, but microbes, small things, bacteria. I think it's important to understand and investigate. Hopefully we find something someday, but we want to make sure we're doing it in the best possible practices. And I think, and a lot of people have pointed out, that if we do send messages into space and they are intelligent civilizations that can pick it up, again, we don't know if they exist. There's a likelihood they do. We don't fully know what that likelihood is, but it's some number. Well, we kind of know what happens when two civilizations come together, especially if one is very different from the other. It doesn't always end well. And we don't want to be on the short end of the stick, as a lot of people point out. I also think there's another just point of, well, when we're broadcasting these messages, even if something is 200 light years away, it would still take 200 years to get there. And none of this really benefits us, right? If we're sending these messages out, it's not like we're going to get a reply tomorrow. If there is a reply, it is in hundreds to thousands to tens of thousands of years. The benefit one sees, I think, is if there is an intelligent civilization, they are probably searching for intelligent life just like we are. And at least we're helping them and their searching and exploring of the universe.
If the universe is populated by more than just life on Earth, why hasn't there been any evidence at all for it as yet? Not even the slightest tinkle.
And you're right. And this is, as you said, lots of people have asked this, dating all the way back famously to Enrico Fermi. And this is like something we grapple with.
It's called the Fermi paradox, isn't it?
Exactly. That's right. And this is something we grapple with, and I think it's very true. And this is why I think the exploration of the solar system is so important, becoming bigger and bigger, because at the very least, if we find some sort of bacteria, simple life, even simply complex life, plants or fish, I don't know, it at least starts us on that path. Because you're right, we have zero evidence any of this exists. And this is kind of a big problem. And as with the Fermi paradox, there's lots of what we call solutions, ranging from space is just very big, so we may never find it. We're pretty confident intelligent life doesn't exist in our solar system. Doesn't mean maybe it didn't even exist in the past on Mars or Venus, but not now. It could be then ranging to we're in quarantine to, we're a giant zoo experiment. There's all sorts of ideas, the solution of the Fermi paradox. And so it does raise the question again, why even put the effort into this when, well, we're not even really sure they exist? And I think it's a lot like that original message in the 74, the Arecibo message. We didn't even know planets existed at that time. We just thought it was likely, even though we've never saw it. So people broadcasted their message. Now we do, and we know there's thousands of planets. So maybe in 50 years we'll know that life exists. Maybe we still won't. I don't know. And I think this is the interesting intersection now that we're at with astrobiology in the truest sense, understanding life in space. There's a lot of things we know. There's a lot of things we don't know. And there's a lot of things we know we don't know. And there's also a lot of things we don't know we don't know. And it's a very weird world, and I think a very important world. And at least these sorts of things get the public discussing what it means and what we should, because if we are doing something as part of the planet, we're not doing it as part of NASA or the U.S. or even North America. You're doing it on behalf of Earth, quite literally in the truest sense. And so properly, I think we want to make sure that those actions are arising at a point where most of the world supports it. And I think we need to have those discussions more before we start launching into a lot of these big new projects.
It's called blue sky science, and it's called that for a reason, because if people don't do that, I think most of the inventions we have today wouldn't have occurred and we wouldn't be living the way we are. Getting back to what you were saying earlier about finding life in our solar system, right now the Mars Perseverance rover and the Ingenuity helicopter are searching for life on the red planet. If we find life on Mars, or evidence of past life on Mars, and it's similar to what we've found on Earth, that wouldn't really tell us much, because Mars and Earth have been swapping rocks for years, millennia. But if we find that on Europa or in the seas of Enceladus, that's a different story then, isn't it?
It is, and you're right. And I think there's a little bit of answer in all of it. As you said, if it's similar to Mars, then we at least know, A, that's not surprising, but it really just goes to show that it's actually Earth that's not special. And we kind of think this anyways, but it confirms we're actually not that special. It is the inner solar system, like Mars, and even further out to Venus. If you find it, as you said, on Europa, Enceladus, Titan, any of these worlds around Jupiter and Saturn that we think could be rich in potential life, that is a very different system, a very different ballgame. And again, if it's similar, well, then, there's something to that. Is it because of the ingredients in the solar system, or is it something that happened in the solar system? If they're different, that is also exciting, because then it's telling us, well, there's lots of different ways of forming life. And I guess it's the same with Mars. If we find evidence for past life on Mars and it does look different to Earth, I think that's very exciting, because why is it so different in the evolution? And I think this is almost the interesting challenge we have in these questions, is we don't even know what path in the road to take. We're kind of at the intersection. We have lots of ways forward. And we at least need that first inkling to know what is the next path and the next steps. And that has to be in exploring some of the moons of Jupiter and Saturn. Even if, in fact, no matter what we find on Mars, I think we still have to do that. Because as you said, how closely related in both composition, formation, and evolution Earth and Mars, and to some extent Venus, have.
Just with Mars, I think the real kicker would be if we find evidence of past life on Mars, but the proteins have the wrong handedness. That would be huge.
Oh, it would. It would transform not just an understanding of space, but biology in the truest sense. And that, I think, is so cool, because you really are opening up the potential for a generally whole new field of science and combination of taking the idea of astrobiology to a whole new level and putting into picture that big question, right? Exactly how did Earth life start? Was it a comet? Was it a rock from Mars? Was it something different? The various ideas that have been put forth, it would really start to put those pieces together of what it may be. And as you said, if it's very similar to that on Earth, that gives stronger evidence that, maybe we did come from Mars or vice versa, or some sort of commonality.
Okay, you've told me about the science. You've told me what other people have thought. What do you think?
I am firmly in the camp of, I believe life exists. And again, this is bacteria, simple cells, that sort of thing. I think it exists in the solar system. I think it's actually probably pretty common. The intelligent life question, I like to frame it into the complex life question, because humans, we are a very self-centered species, right? We always ask the question, let's find things like us. Why don't we ask the question, let's find things like dinosaurs? They were on the planet for longer. There was a lot more species of them. Statistically, they're more likely to be dinosaurs in space rather than humans. We just think an awful lot of ourselves. Now, that's not wrong. That's not unsurprising, but that's reality. And I think complex life, big things probably do exist. I hope intelligent life exists, but I think in all likelihood, because of how big space is and the small amount of time we are on for a planet, it's just unlikely we're going to get that answer anytime soon. As sad as that is, I don't think, and not even soon, in generations, that is going to miraculously pop up and we say, hey, we found evidence of intelligent life, unless it's on Mars or in our solar system. I think because of the vastness, unfortunately, of space, that's going to be the limiting factor and always be this question we have. But I do think we'll get an answer, at least, yes, life does exist somewhere else, again, in our solar system. And, what it may look like, that's really exciting. That's what, I want to know. And I always like to end on this. I don't actually worry about aliens. There's this discussion that should we worry about contacting them? I don't, because I think it's A, unlikely, and B, I actually worry more that not that life exists, but that we are the only place that has life. If we are the only place that any sort of life has ever evolved with, that I think is a bigger, scarier answer than the one, life is just common.
That's Brad Tucker, an astronomer with the Australian National University. And this is Spacetime. That's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.